All right, so remember we said yesterday the last questions are kind of the important ones. So I think I posted even the solutions. I think I did. Does anybody want me to go over any of these questions right here? Yes. 21. Yeah. Now this one I think is a really important one. So what I'm going to do is I think I'm going to go ahead and draw this triangle here. And I think this is the key to getting these correct when they overlap. G, H, 10, this, and this. Oh, and this is 7. So what I'm going to do is, J. And this is what I'm hoping you do on your iPad. Just kind of move it over. And then you do the other one that they're talking about. And then you go ahead and mark the figure. This is 2x minus 2, 7. And then once you do that, you could probably now write the proportion. They're similar by angle similarity. Do you agree? So I know that I just write the two sides of the triangle that is known. 7 over 10 is equal to, and then what I do is I say, okay, 7 is between 1 and 2 tick marks. So that means 7 corresponds to what? 2x minus 2. And then we could say that 10 is between 1 tick mark and no tick mark. Uh-oh. Oh, I left DH off, that's why. DH is 2x plus 4, right? So that's how I knew it was 2x plus 4. Do you agree with that? Now, listen, this is just helping with your algebra, so look up here for me, please. Does everybody see I can divide this by 2? Right, so I always like to make problems easier. Does everybody agree with that? Everybody see that? All right, now when you cross multiply, 7x plus 14 is equal to 10x minus 10. 3x equals 24, so x equals 8. How's that? You good with that? All right. Hopefully you guys understand what I'm saying about separating the triangles when they overlap it's a big help. All right, big help. Yes, sir.
Could you do number 20?
Yeah, let's look at 20 now.
And before you do that, I also have a question.
Yeah.
So when you're making a fraction, how do you know which one is the denominator and which one's the denominator?
It makes no difference. Remember, look, you could have written this 10 over 7 equals 2x plus 4 over 2x minus 2. It's the same answer.
Okay.
You could have also said 7 over 2x minus 2 equals 10 over 2x plus 4. There's lots of different ways. We just make sure that they're correct corresponding sides, correct? You see what I'm saying, right? You can go small to large, small to large. You can go side to side, side to side, as long as they're corresponding. And again, I like these questions because on the SATs, a lot of times you're dealing with similar triangles, and they always put them overlapping because they know kids can't do it. So that's why I'm saying, please take the time, make sure you're doing these. It's not that hard if you practice. Now you wanted 20?
Yes, please.
Okay, so now on 20, you'd have to just come over here and say, if that's 36, then this is 54, right? Now, once again, if I'm doing this, I'm just automatically putting 15 over 25. You agree with that?
Yeah.
So I'm going to put 15 over 25. And then 15 is between the 54 and the 90. You see that? So that means this is between 54 and 90. So that has to be x. Correct? And then 25 is the hypotenuse. So the hypotenuse is 10. How's that? And again, I always tell kids reduce if you can. So I'd make that 3/5, and then I'd say x equals 6. Much easier. See that? Reduce fractions when you can. It's all about proportions. Should be super, super easy. All right, super easy. Anybody else? Anybody else? Anybody else? Come on. 24. All right, so Taylor sees the nest of a rare bird near the top of a tree. He wants to report its position to the local conservation group. Taylor is 6 feet tall and casts a 3.5-foot shadow. The tree with the nest casts a shadow of 6 feet, about how far above the ground. So essentially what you're doing is you're just doing this, correct? Here, here. That's kind of what we're doing. Now, if you understand that his shadow is 3.5 and he's 6, and the tree, now, the tree's shadow would be, let me erase this. Does everybody agree this right here would be the tree's shadow? That would be 6. So this is a common problem as well. So the height of the tree is x. So it's just 3.5 to 6 is equal to 6. The 6 feet is how tall. So x is here, shadow is here. All right, 3.5 is the shadow. And this is the height. Does that make sense now?
Yeah.
All right, cross multiply, divide. Anybody else have any issues? Okay, so today, believe it or not, another simple day, just proportions, it's all it is. All right, so if you're good at proportions, you're good with today. All right. Except yesterday we had what? How do you prove triangles are similar? Angle, angle, similarity. Today we have the two other ways. One way is side, angle, side, similarity, and side, 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 similarity. All right, what exactly does that mean? Sides must be what? Sides must be, yeah, proportional. That's all it means. All right, if a triangle is similar and all 3 sides are proportional, then they are similar automatically. If you have 2 sides and an included angle, only side angle side works. Angle side angle does not work. Side angle side. Is everybody with me on this? All right, so the 2 sides must be proportional. Do I agree? And the included angle must be congruent. Remember, angles are congruent, sides are proportional. It really is just really simple, really, really simple. All right, but once again, you got to do the work. All right, so let's try to knock it out. All right, determine whether the triangles are similar. Now, the problem everyone always asks me is this: how do I know what number goes with what number? Does the 36 go with the 30 or does it go with the 27? Which one? Why? Why? It looks more proportional. I don't like that answer. Tell them why. Yes. Tell me, Morty. Now, come on now. You can't lose your streak here.
So the 30 goes to 27, so we can divide by 3.
Actually, that's not a bad thought, but it's still not the best. What? How do I know that? You're right. You don't. So you can't say that. Go. Nope. Not a bad thought. Tell him. Yeah, but it has nothing to do with the vertical angles. I'm just telling you, this is the hardest problem, and I never understood why kids don't see it so obvious. 36 and 40. This is the key. 36 is the small number, right? 40 is the what? Large number. So bear with me. Therefore, in order for them to be proportional, the 36 must go with the what? Must go with the 27, and the 40 must go with the what? 30. Now, I just think that's obvious, right? But I've said that over the years, and people say, I don't know what you're talking about. How did you know that? Well, if you're going to make fractions that are equal, think about it now, because I think I've got it so everybody can understand. If I put the small number over the large number, is it possible that that's going to be proportional if I put the large number over the small number? Now, come on, you got to listen to that now. If I put small over large, that number is going to be more than 1 or less than 1?
Less.
27 is 36 over 40 more than 1 or less than 1? Less than 1. So if I put a larger number over a smaller number, it's going to be what? It's going to be greater than 1. So is that possible that they form a proportion? No. Right? So again, like I said, every year I say, I don't know how you can mess it up, but every year people mess up these proportions because the triangles can be twisted, right? They can be alternate interior angles. So they're across from each other, the proportional sides. But I never had to worry about that because all I did was I matched the small side with the what? Small side, and the large side with the what? Large side. It can't be reversed. There's no way for it to be reversed. Small over a large has to equal a small over a large. It's not possible small to large is proportional to a large to a small. All right, I hope that makes sense. Yes, sir. Yeah, there are multiple ways to set it up. Absolutely. The proportion can be set up multiple ways. All right, but I think to get it right, I always look at one triangle and put the small to large or large to small. Then I automatically know what to do on the other one. All right? Does that make sense?
No.
What? Well, let me go ahead now and just set this proportion up. All right. So I want the small side or the small measure to be 36. And then you can say that's over what? 40. And then the other one would be what? 27 over 30. Is that a true statement? If I divide by 4, I get 9/10. Divide by 3, 9/10. That is correct. So now we know that they are similar because the sides are proportional and the included angle is congruent. All right, so we would say that's by side angle side similarity. And then they want you to write the similarity statement. So again, triangle LMN is similar to, all right. So now, does everybody agree the 36 corresponds to the 27, right? So LM corresponds to OP, right? OPN. All right, for whatever reason, people mess that up. I don't know why. Yes. Well, because the sides are proportional and the included angle is, right? That's what that is. And in a minute, we're going to do what? Side, side, side. That's all just looking at all three sides. All right, so over here, all right, now here we should again recognize that it is a right triangle. So if I wanted to, 3, 4, what's the other triple? 5, good. 3, 4, 5. So this one over here is going to be 6, what, 10? 6, 8, 10, right? So we could do this either way now, right? Does everybody see? Now, if I'm doing side, 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 watch how I do this. 3, 4, 5, small to large. 6, 8, 10. And if I do it like that, all those reduce to 1/2. All right, so I could say side, side, side. I could also say in this case, side, angle, side. Side, angle, side. Everybody good on that? All right, so now we have triangle ABC is similar to, A is the right angle, so it's definitely F. Then it's the short side. Does everybody agree? So F, D, E. And notice how 3 really isn't the short side, right? See how they're trying to mislead you? All right, that doesn't make sense. All right, let's knock out 3 here. All right, so again, it's very simple. Small to large. 6, 8, 12. 4, 5, 8. Does everybody see how I'm doing that? Are those similar? No, not similar. Anybody have any questions? Told you, very easy. Over here, small to large, 10, 15, 20. Small to large, 4, 6, 8. Now, are those the same? 5 halves, 5 halves, 5 halves. So what? Yes, by side, 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 similarity. Again, I like to write alphabetical order. So triangle JKL is similar to triangle. So it goes from the long side to the short side. So SQR. I hope everybody's trying that. Everybody see it? Easy, easy, easy. Uh-oh. Now we have these graphs. Sorry, guys. I'm not a fan either. So here we go. Grab number 5. We got to determine if they're similar. And it looks like we just have to check out the 3 sides, correct? So why is that annoying? Come on, tell me why it's annoying. So why is that annoying? So how many times do we have to do the distance formula? A lot. How many times? 6 times. Right? We have to do it 6 times. That's why I'm saying if you know my little shortcut, the distance formula is not a big deal. All right, so we're going to practice the shortcut with the distance formula. But again, I really need everybody to be able to tell me what the distance formula is. The distance formula I want you to say is the Pythagorean theorem, correct? Right? The distance formula is just the Pythagorean theorem. All right? So remember the distance formula. If you can't tell me what the distance formula is, make sure you write it down. X2 minus X1 squared plus Y2 minus Y1 squared. So let's plot these points, 10, negative 2. And then negative 2, 4. And then 6, negative 4. All right. Now let's see if this is accurate. Does everybody's triangle look like that? Hopefully it does. 10, -2 is L. -2, 4 is M, N. Okay, so now let's just look at LN if you have that. Right? So here and here is the right triangle, correct? So this is 2, and this is 4. All right, look up, because I'm trying to help you. All right, look up so I can show you. I'm trying to help you with the math and how you can do better. All right, I want everybody to remember 2 is the same as 1 times, well, 2 is the same as 2 times 1. This over here is the same as 2 times 2. So this answer is going to be 2 times something. And it's going to be 2 times what's left. Uh-oh. Yeah, you're right. This right here is a 2 and a 1 left, correct? So this side is 2 square roots of what? Very good, 5. How did we get 5? Because we just did 1 squared plus 2 squared. So wait with me on that? Now, let's say you don't know what I'm talking about. Look what happens. If I say 4 squared plus 2 squared, 16 plus 4 is 20. Square root of 20. Square root of 20 breaks down to 2 radical 5. Does everybody see that? Notice there is a common factor, 2, 2, 2. That's what I was trying to show you. So to me, the math comes from the fact that you can take this 2 because it's a common factor and not do it, just pull it out. And then I just say to myself, okay, what's 2 squared plus 1 squared? 2 squared plus 1 squared is the square root of 5. All right, hopefully I'm making sense. All right. Ugh, now we got a long one. All right, so let's figure out this guy. Uh-oh. I like to use the highlighter on these. From here to here, here. All right, how much is that? 8, right? And this is what? 8, wow. Okay, so come on, guys. It's a nice one. So this over here has got to be 8 times something, right? Who can tell me 8 times what? No. Remember, this is 8 times 1. This is 8 times 1. So we just want to do the, say it. No, we already did 8. Stop with the 8s. There's no 8. It's just what? Yay. Come on, guys. Come on, please. I'm trying to make you better with numbers. All right. Think about what I'm saying. All right. Does everybody agree there's a common 8? So if I pull out the 8, there's just a 1 left and a 1 left. So you're doing the Pythagorean theorem with 1 and 1. I'm not trying to trick you. 1 squared is what? 1. 1 squared is 1 plus 1 is square root of 2. So this side right here is 8 radical 2. Now let's say you have no idea what I'm talking about. I'm trying to show you. If I do 8 squared plus 8 squared equals c squared, 64 plus 64 equals c squared, 128 equals c squared, c is equal to the square root of 128. Do you really feel like breaking down 128? No, but that wouldn't be that hard. It's what? 8, well, it's 64 times 2, which is 8 radical 2. I'm trying to show you, if you can observe, it's much, much easier. All right, recognizing the common factors in the triples. Yes.
So why did you do 2 times 2, like, over there? How do you know what?
I'm asking you, over here, the first 2 legs are 2 and 4. What's common? There's a common factor. 2. So that leaves you with 1 and 2. You do the Pythagorean theorem with these two numbers. You with me on this? Just like over here, I have 8 and 8. So 8, 1, 1. Pythagorean theorem with these. All right, let's see if I'm making any progress here. So now I'm going to do the other side, right? And let's go from here all the way over to here. All right, what's the top one? Did I count yet? Is that 12? All right, and then what's the other side? 6. Yay. Okay, okay, okay. Here we go. So now let's practice. I have 6 and 12. Come on, guys. 6 and 12. What's common? 6. So this is a 1 and a 2. So the answer is 6. Yay. Okay. I feel better now. 6 radical 5. I'm telling you, if you participate, right, part of being good at math, the concepts are not hard. It's all of the algebra that's hard. All right. So that's why you're trying to get better at that. So that's 6 radical 5. Everybody good with that? All right. So the 3 sides are, somebody tell me, I forgot already. 3 sides are 2 radical 5, 6 radical 5, and 8 radical 2. Now, which one's bigger, 6 radical 5 or 8 radical 2? 6, what's square root of 5, roughly? 2, roughly 2. Why is it roughly 2? Because square root of 4 is what? So square root of 5 is a little bigger than 4, right? So 6 times 2 is what? So it's a little more than 12, right? And then what's the square root of 2? 1.4. In other words, it's less than what? Less than 2, right? So that's going to be less than 8 radical 2. Or 8 radical, that's less than 6 radical 5, sorry. So 6 radical 5 is the largest. So I'm going to rewrite this. I like to put them in the right order. All right. Now I'm going to do PQR. These better be proportional. That's all I have to say. All right, so here we go. We're going to do the one on the bottom here. All right. Kind of does, doesn't it? All right, does everybody get that? Something similar to that? Everybody agree? All right. So -1, 5 is P. 2, -1 is Q, R. All right, so let's do the small one first. So again, all right, so what's that? 2 and 2, so this is going to be 2 radical 2. Thank you for saying that. Right, 1 squared plus 1 squared, right? All right, so here we go. Let's try the other one. One, 2, 3. 1, 2, 3, 4, 5, 6, right? Okay, come on now. So this is going to be 3 radical 5. Good job, guys, because 3 is the same as 3 times 1. This is the same as 3 times 2. All right, I'm pretty happy with that. All right, now let's do the other side. All right. What do I have? 4 and what? Well, that's not good, is it? I don't like that at all. Am I right? Is that right? Did anybody else get that? Come on now. Oh, so that's the square root of what? Wait a minute. Are you, some of you having trouble with 25 plus 16? 41. So is it safe to say now? Not similar. Square root of 41 has nothing to do with the other ones. I thought it was going to work out because we could put the 3 radical 5, right? I was thinking with the 2 radical 2, and then over here is a 41. Those are not going to work. So we wasted a whole bunch of time. Thank you. Not similar. Unless we did something wrong. Did anybody else? All right, so the next one's going to be what? All right. So if your name is Davis, you have to do that problem. Number 6, and Morty. If your name is Davis or Morty, you have to do that. All right. Here we go. So let's look at 7. All right, here we go. In the figure, AB over DE is equal to, all right, so let's look. AB DE is equal to BC over EF. So we have a choice here. I can name what angle? What angle can I name? Okay, well, because it's a triangle, you can name it with one letter. E and B have to be equal. Then that would be what? Side angle, side, similarity. Or I would just have to show what? That AC is the same proportion. Right? Those are your options. Do you agree with that?
Yeah.
So what are they saying? Yeah, well, definitely not A.
It's letter C.
Letter C? All right, thank you. B and E. All right, I'm good with that. All right, let's look at number 8, because these are ones that are important, the word problems. All right, the goalposts at North High School football field cast a shadow 50 feet. The distance from the post to the shadow of the crossbar is 16 feet. If the crossbar is 10 feet above the ground, how tall is the goalpost? Yes, that's how I would do it. Tell me again. All right, 10 over 16. And again, the reason that works is because that's a right angle. All right. So the height over the shadow is equal to the height over the shadow. All right, so cross, multiply, divide, knock that out for me. X equals, somebody help me?
31.25.
31.25 feet. Now, as I'm saying always, if your calculator's not out, you should be calculating. All right, you shouldn't say, oh, it's right. So I'm just going to write 31.25. All right. There's a lot to be said in doing the work, not just setting it up. Make sure your proportions are correct. All right, so I'll work a couple more with you. Here we go. Let's knock out 9, 10, 11. All right. So the small triangle for number 9, what are the sides of the small triangle in order? Say it again. So in my opinion, you should write 5, 8, 10. All right, now the hard part. The small side, 7. Then what?
11.2.
Thank you. And then what? 14. Thank you, guys. Now, obviously, 10 over 14 is 5 over 7, but the problem is 8 over 11.2. So you take your handy dandy calculator, do 8 divided by 11.2, math, enter, enter, and hopefully it's 5/7. Is that 5/7?
It is.
Yes, I think it is. I think you're right. Now, again, I'm telling you just how to use your calculator now. Right? Just write 8 and 11 over, or 8 over 11.2, write that as a fraction, and it comes out to be what? They all become 5 over 7. 5 over 7, 5 over 7. Does anybody have any doubts about that? So then this is by side, side, side similarity. All right, again, I just think this is the easiest way to set it up. All right, the easiest way. All right. Math, enter, enter. Convert 8 divided by 11.2 to a fraction. You got it now, right? Again, it's just reviewing how to use your calculator. It's been a while. All right, so on number 9. Ooh, this is a good one. Or I'm sorry, number 10. Well, it's dealing with an angle, right? So that means the quickest way is to try to find another angle. Do we know it's a right angle? Is QS parallel to RT?
We don't know.
What do you mean it might be? I think I know.
Yes.
Well,
Oh, shoot. Wait. Because of corresponding.
not corresponding, but
Alternate.
alternate interior angles. So this is parallel. Does everybody agree? Okay, is QP parallel to ST? We definitely don't know that one. Well, why?
Because it wouldn't work.
Yeah, you're right. It wouldn't work if they weren't parallel, but the question is, can we tell just based off the picture? And the answer is what? I don't think so. Hold on a minute. QPS. Is this angle congruent to what? It's very possible. But they're missing something important, right? I wish on this figure they would have done this. Then you would be correct. You agree with me now? Yeah, you can't say that. You can't say that they're right angles. You can't say, because we don't know that ST is parallel to QP. Yeah, but I'm agreeing, but they don't tell us anything about that. Right, think about if I did this. I could make ST like that and not change the picture. Do you agree? Right, the angle hasn't been affected, right? So it doesn't say that ST is parallel to QP, so I don't know about that angle, right? If it would have told us those angles were congruent, then yes, we're good. All right, so I say no, not enough. All right, so let's look over here. Yeah, this one's kind of annoying, right? So I have AF is 6. So that's this. And then I have this is 6. So I'm looking for, obviously, side angle side. Does everybody agree with that? So side angle side, that's what I'm looking for. So the 38s are equal. Oh, I didn't even see this 9. Yes, well, no, that means from here to here is 9, I'm assuming. From F to B, it looks like 9. That's what I'm thinking. And from A to F is 6, right? So that means AB is how much? 15, right? So I have the big triangle, I have 10 and 15. On the small triangle, I have what? Where does the 6 go? On the left, and then 9 goes over here. Does that work? Because 10 over 6 is? Yes. So then this is side angle side similarity. Everybody agreeing with that? All right, again, I think those are good problems, and those are the ones that you see kind of on standardized tests, because if kids don't know, it's just not possible, right, to figure it out. All right, so I think you guys can figure out 12 through 17. Oh my goodness.
I'm gonna Christmas tree that one.
And what is different, right? And what's different? So we got to do one of these. So let's do 22 has a 16. That has a half. All right, I found one that doesn't have any decimals.
First one looks so-
Yeah, I'm afraid to do the first one because we did the first one and it was a failure. All right.
But that one happened.
So,
You
okay.
didn't do that twice, Mr.
All right, so do 18 and 19 then. We'll see. What was that, Marty?
Or 19.
No.
Yep.
All right. 18 and 19 or
Just 19.
just 19.
All right, that's 19.
That's your option. All right. So now listen, everyone, please make sure that you set these things up. These really are the important problems, 12 through 17. I also want you trying 19. And then I want you looking at 26. All right, 26 is the word problem. All right. So there's your assignment. 12 through 17, 19 and 26. Anybody have any questions? All right. Have a great day, my homeschool peeps. Hopefully everybody's doing well, staying out of trouble. Yeah. All right. See you guys tomorrow.
Thank you. Have a great day.
Take care.